Okay, so as promised, here is the video for 11C from the review packet. Earlier in 11A, we got that y prime or f prime of x is negative 2x plus 4 over x cubed over 2 factorial plus, sorry, not plus, this is a minus 6x to the 5th over 3 factorial plus 8x to the 7th over 4 factorial minus 10x to the 9th over 5 factorial plus so forth and so on. Okay, so the argument that I need to make is that this can be written, and I kind of skipped a step in my notes there in the answer key, but let's see if we can follow this out. Started at 1, okay? If I start at 1, then the negative, when it's 1, works. When it's not 1, doesn't work. So let's make that negative 1 to the n, right? The numerator is 2, 4, 6, 8. So that's 2n. And then I have x to the, well, it's going to be 2n minus 1. Okay, so this is 2n minus 1. Okay, and this is going to be over n minus 1 factorial, right? Because, or no, sorry, that's not correct. It's just n factorial, right? Because the first term is 1 factorial, 2 factorial, 3, 4. Okay, so take a minute and try to convince yourself that this is going to yield that series. Okay, so the problem that I'm going to bump into is that I need to compare this to y. So the counter in y actually starts at n equals 0. The other thing I notice here is I have an n in the top and an n factorial in the bottom, and I can simplify that. So let's actually just go ahead and simplify that. So I still have the negative 1 to the n, I still have the 2, I still have the x to the 2n minus 1, and if I take n away from n factorial, I now have n minus 1 factorial. Okay, so that's there, and let's take the next step. We have to change the counter. So I need to go from n equals 0 to infinity, which means that if I change that, then I want 0 to land on 1, so this has to be n plus 1. The 2 doesn't matter. This has to go up by 2, right? So this is currently 2n minus 1, right? So I'm going to get 2n, and if I make the n into n plus 1, this is going to give me 2n plus 1. And the n minus 1 has to go up by 1 as well, so that's n factorial. Okay, so try to convince yourself again that this creates this, right? Because if I put in 0, I get a negative 1, right? That's 2 to the first, 2x to the first, right? Over 0 factorial, which is 1, right? If I put in n as 1, I'm going to get a positive, which is what I have. And then 2 divided by 1 factorial is 2, which is the same as 4 over 2 factorial, which is 2, right? X to the third, because 2 times 1 is 2, plus 1 is 3, okay? And then I get a negative, right? 2 over, this time it's going to be 2 divided by, let's see, this is 0, 1, 0th term, first term, second term, right? So 0 divide, so this is going to come out as 2 factorial, which is 2, right? Okay, so that's 2. And let's see, 6 divided by 3 factorial. 6 divided by 6 is 1. 2 divided by 2 is 1. So that works. X to the 5th. So this is good. This is actually producing that series. Okay, so hang on to this, right? This is y prime. Okay, now I've got the original series, but I want 2x times y. So that's going to be 2x times the series that we started out with in the problem, right? So the original series in the problem, if I look back, is the sum from n equals 0 to infinity of -1 to the n times x to the 2n over n factorial. So if I distribute the 2 into that, I get the sum from n equals 0 to infinity, -1 to the n, 2. Now x times x to the 2n is x to the 2n plus 1, still over n factorial. Now, take a look at that. These things look almost identical, except this one has an n plus 1, and this one has an n. Okay, so let's try this. This means that if I factor out a -1 from the first one, right, that's going to give me n equals 0 to infinity, right, -1 to the n, 2x to the 2n plus 1 over n factorial, plus the sum from n equals 0 to infinity, -1 to the n, 2x to the 2n plus 1 over n factorial. Okay, so these and this are identical. So this works out to be like y times -1 plus 1, because this is y, right? This is y, or sorry, that's not correct. Not y, this is 2xy times -1 plus 1, right? So this means that on this end, I put in y prime plus 2xy. This was y prime. This was 2xy. I added those together. And I ended up with 2xy times -1 times 1, right? So I factored out the 2xy. But -1 times 1 is 0. So 0 times 2xy is 0, which is what I set out to prove. Okay, so it's a little bit of manipulation there. But I think it's a clear explanation. If you want to go back through, listen to it again, and see what you got. And if there's some point in here just that's not making sense, just send me an email and I'll see if I can help.